So welcome back to SASM, the super assembler. Just kidding. SASM is the simple assembler. In the last video, we talked about the different aspects of setting the SASM environment for different assembly syntaxes and processor architectures, 32-bit and 64-bit. And we said that we would concentrate on the 32-bit implementation, right? And we probably implemented a simple add program in the NASM assembly syntax that is based on the Intel's syntax of assembly. However, these tutorials on SASM will be based on the GNU-based AT&T Syntax of assembly programming language. And we already know that the difference between the Intel and the AT&T syntax is similar to a language that has two different accents. And no one syntax has advantage over the other, except that it is matter of convenience for the two communities who work under different platforms. So the AT&T syntax is used by the Linux Unix community, and the Intel's syntax is preferred by the Microsoft Windows community, okay? And for anyone who wants to understand the difference between the two, should visit my video on Intel versus AT&T syntax. So once upon a time, I started recording videos on SASM, but then I realized that first learning the assembly language is more important than this pack of tutorials. But since now we are experts in assembly, hooray! We will be having a lot of fun in these tutorials, and I promise to upload some cool videos without any further delays. Tech Instance has more for you at store, so I encourage you all to subscribe this channel and don't forget to hit the bell icon to receive important notifications. And if you have any questions, feel free to comment in the comment section below. So just to summarize what we said from the last time, so we already know that SASM is a very syntax-friendly simulator that is translated to many languages. SASM supports working with 4 types of assemblers: NASM, MASM, GAS, and FASM in 2 modes, 32-bit mode and 64-bit mode. We would concentrate on the x86, that is 32-bit implementation. You can choose mode settings on the build tab, right? Also there, you can change assembler and linker options and choose programs for assembling and linking as well, okay? Just to be brief on the types of assemblers, MASM is the Microsoft assembler, and its use is limited to the Windows operating system, whereas NASM and GAS is a cross-platform x86 assembler that supports Linux, Mac operating system, and Windows. NASM and MASM are based on the Intel's syntax of assembly language, and GAS is the GNU Assembler that is based on the AT&T assembly syntax. Many GAS source code files use the C preprocessors instead of GAS own macro support. Then we saw the real-time code formatting characteristic of SASM, which highlights the code with different colors as we are writing it. Well, this is available in majority of simulators and programming languages, so no big deal on this one, right? Now let me show you the environment that we are going to work in. Here it goes. This is the SASM graphical user interface. It's very good looking, right? The most prominent thing that you see in this diagram is the colorful and pleasant looking interface, the real-time code formatting system that highlights the code with different colors as we are writing it, okay? SASM supports working with many open projects. New files are opened and created in new tabs. And at the exit from SASM, the current set of open files are saved. At the next start, you can restore previous session. This is the input docking area where you can input your data, or in other words, you can get values from the user, similar to how we get information from the user through the command prompt using the scanf function in C programming language. And this is the output docking field that is used for displaying your results, okay? Similar to how we display things in the command prompt using the printf like C function. This is the place where you can see all your variables or register values when you are in the debug mode, okay? And this is the area wherein all messages and compilation errors will be shown in the bottom over here. And these error messages are something that you would get to learn through your experience with the programming, with this programming environment, right? Okay, so that was a brief recap into what we did long time ago in my previous video on SASM. Okay, so in this tutorial, we are going to write our first Hello World program in the GNU-based assembler, also called GAS, that uses the AT&T syntax of assembly language. Let's dive in. So I welcome you once again to SASM, and this is the interface that the GUI of SASM that we talked about in the previous slide. So let us set up our basic structure, our basic template that will include all part of our assembly program. If we start a new file, we know from the previous video that it will give us a nice template from where we can directly start writing our code. Okay, so let's discuss this template a little bit. So what are the basic parts of any program? We would need a section for data where we have all the initialized data. Okay, then we have a section for our actual program. This is where our program goes in. Okay, then we have a section for uninitialized data. Okay, so BSS is the section where our uninitialized data. Okay, but since we don't have any uninitialized data, we can remove this section. Okay, do we have to include the data section? Well, yes, because we are writing our Hello World program. So we would require the data section for the string that we want to display. So a string, we know, is a simple array of characters that are 1 byte long. So we declare our string variable or label message, and the syntax ASCII, and this is the message. Tech instance says hey world. Okay, and the \n is for the new line. In the text section, we are going to declare a label main. That is, as we said, a memory location, and we need to declare it as global. Okay, so the global here says that this is a global variable that can be accessed outside our program. So this actually is where our program starts. Main, and main is a memory location. Okay, and this is also visible to other programs. So it is a good practice to compile your program for any errors, to check whether your template is working correctly. So we use this simple instruction move L, and we want to move this immediate value 100 into EAX. Okay, and return. So let's see if our program is working correctly. So you can see our program works correctly, and we can go to the debug mode to see the variables and registers in the register docking area. So we will choose this step over, and we can see this value. We want to make sure that EAX gets the value 100, and that's correct. So the program is now working, and we can start coding here. So now we can start writing our code. The first step of any program is to set up the stack for our main function. So we need to push EBP onto the stack, and we need to move the value of EBP into ESP, or we need to declare another pointer ESP, so that now we can push the message onto our stack. Okay, with this $sign. This is the AT&T syntax of assembly. And we will use the printf function for printing our string instead of using system calls. So we will call printf. Okay, and the last step of any program would be to finish the stack for the main function that we have just created. Okay, so we will use we need to move our stack pointer ESP to EBP. Okay, and then we need to pop EBP. Okay, so that's it. That's almost complete, except that we need to tell the assembler what the printf function actually is. So we need to tell the assembler that this is something external to our program. So we need to use this keyword external printf. So hopefully this program is going to run correctly. This is let's build it, and we can see built successfully, and we compile it and we can see the program finished normally. So here we see the message tech instance says hello world. If we place a new line here and we place a new line over here, is going to give us a nicely formatted message tech instance says hello in the output docking field. Okay, let's go into the debug mode and see if things work correctly, and we will use the step over mode, stepping over until we push the message and we print the results, and we finish the stack setup and we return. So we see on the right side the message tech instance says hey world. So this is the current working directory, but since we haven't compiled our program into the current working directory, we need to find object file. So this is our object file. And if we open the file location, this is the object file that has been created for us. We copy it into our working directory, and this is our hello world program. Paste it here. And now we go to the command prompt. Okay, we go to the command prompt because we want to link it to an executable. Okay, so let me share this screen with you. Okay, so we go to our working directory, that is the new SASM. Okay, and if we show the directories and files, here is the program .o, the object file that we have. We link it through GCC with the wildcard O, and then we give the output file and the input program .o. Okay, so if we compile, if we link, so this command basically helps us link the object code into an executable. Okay, so it has done successfully. If we show the directories, we will find something that is named as we expect, program.exe. Okay, and if we run this program, we would get something like we got in our SASM simulator. Tech instance says hey world. Okay, so I hope that was cool, and thanks for watching.